Hello, I am Justas Dainys and I will talk about the work we do to assess recreational fishing effort in Lithuania and our attempts to apply fixed-wing drones and anonymous fish finder device data to count the number of anglers. Assessment of recreational fishing effort has always been hard and time-consuming. In many countries we have no idea on how many fishers there are and how much do they fish. Until recently Lithuania was one of those countries. We know how many annual fishing permits have been sold each year, but there is no information on how often anglers actually went fishing. The reason why this is especially interesting in Lithuania is because almost all commercial fishery was banned in inland waters in 2013. Since then, fish stocks started recovering rapidly, or at least this is what initial assessment shows. However, angling now is a major source for mortality for fish in lakes, rivers and water reservoirs. So it is important to evaluate what effect angling might have on different fish species and stocks. To do that, we need to know several things: how many anglers fish in a given water body, and what do they catch. Traditional methods for angler counting are often expensive and time-consuming. These methods include phone or postal surveys, which become less and less effective. Manned aircraft can be used, but it is expensive, and vessel-based counting or creel surveys on foot are time-consuming and can be inaccurate. Fixed-point time-lapse cameras can be good, but only cover one area and may require long post-processing time. And some researchers started using drones, usually quadcopter drones, but some previous studies concluded that such drones may be not suitable for angler counting due to short flying time and distance, low payload capacity, high sensitivity to weather conditions, low accuracy, and long post-processing times. So what have we done? We decided to try fixed-wing drones equipped with two RGB 4K cameras, and in a collaboration with company Trust, we developed a fast and effective method and tested it in Kaunas water reservoir, which is the largest artificial water body in Lithuania and a very popular angling destination. The fixed-wing drones are less sensitive to weather conditions. They can fly in very high winds and let's say in minus 20 Celsius degrees. They have longer mission duration, higher payload capacity, and they fly fast. This means that we could survey an area of approximately 35 square kilometers or nearly 60 kilometers of flying distance in 1 hour, and you can see the trajectory on the map shown in blue and yellow lines. We could also cover 2/3 of the water reservoir due to flying restrictions of Kaunas International Airport, and the drone had two cameras which had forward and side facing orientation, and this allowed us to see anglers under the vegetation. To calibrate angler counts from drones, we also performed counts using traditional methods such as vessel-based counts during open water season and visual counts from land during ice fishing season. And the visual count points are shown on the map with red dots. And it is worth to mention that the drone finished same route almost 3 to 4 times faster compared to traditional methods, which was already a big advantage in terms of time efficiency. And in this slide you can see a short video of how drone footage looks like, and you can see that boats are visible quite clearly, and anglers from the shore can also be counted fairly accurately without compromising any privacy issues. So in total we performed 40 drone missions and 5 angler counts using traditional methods. To evenly cover all year, each season had 10 drone missions separated into 6 missions during working days and 4 during weekends. During these 40 drone missions, we counted almost 3,000 anglers in total, and during 5 surveys by boat or from the land, we observed about 400 anglers. The angler count in drone and boat or land surveys were generally very similar, both in open water and ice fishing season, and also we should remember that the assessment time is not exactly the same because of traditional method surveys took much longer. The only challenge was assessing the angler number in boats, when the decision had to be made how many people per boat should be considered as anglers. The drone team made a decision to count only 1 or 2 anglers per each boat, but during traditional surveys, even 3 or 4 anglers per boat were occasionally observed. This is a known challenge that might be hard to resolve in drone surveys without spending a lot of time on video analysis. To estimate and predict the total number of anglers within the surveyed reservoir area and time period, which means mornings only, we used angler counts from these drone surveys in a linear model where angler number were modeled as a function of weekday or weekend, season, let's say open water or ice conditions, cloudiness, and wind conditions, including their interactions. And the best selected model included the interaction of ice cover with weekend or weekday, and the second best model only had the weekend effect. And overall conclusion could be that significantly high number of anglers are observed during weekends, especially on weekends with ice cover. The next part of our research was related to analysis of sonar data, and deeper sonars comprise a set of portable wireless sonar-based fish finders, generally used by anglers for fish finding, depth measuring, and making bathymetry maps for their personal use. And the anonymous sonar usage information for Lithuania was obtained throughout the collaborative agreement with the deeper sonar company in accordance with the data privacy and protection requirements. The dataset included individual sonar use events identified throughout the unique encoded sonar user ID, time, and coordinates of a starting point. And to estimate the probability of sonar use on each of the 40 drone survey days, we used Bayesian methods. And this probability combines the probability that angler who fished in the reservoir on that day own and use a deeper sonar device on that specific fishing trip. And here you can see an example of one survey day, how angler distribution looks like, and red dots are sonar users and blue dots are anglers observed during drone missions. And it is clear that many anglers fish in the area that could not be surveyed by drones, and such angler distribution partly might be determined because this area is closer to Kaunas city. And in our Bayesian analysis, we found that probability of sonar usage by anglers had fairly narrow intervals, and here shown as a probability density plots. So we estimated that about 2% of anglers are using the sonar device during the open water season, and this share increases up to approximately 15% during the ice fishing season. And this is mainly because this device is much more popular for ice fishing. So finalizing both methods, I mean linear model using only drone data and Bayesian models using sonar data gave similar results on angler numbers in the morning of surveyed area, which is approximately 25,000 of fishing events. And when extrapolating to the entire water reservoir and all times of the day, we get approximately 110,000 of fishing events throughout the year. So we can conclude that fixed-wing drones and fish finder devices have high potential for assessing recreational fishing activities through the space and time. The final angler counts in drone and boat surveys were very similar, however drones took significantly shorter time to complete their mission, and the recorded video material can be reanalyzed and used in other research in the future. And currently our collaborators from Trust are working on infrared camera usage and automated image analysis, and we hope this will greatly increase accuracy and further reduce the post-processing time and cost. So, thank you for your attention, and more information about our project you might find on www.sif.lt.